Bom, boa tarde, pessoal. É muito prazer estar aqui com vocês nesse mais uma vez um painel que a Covestro está participando aqui na FEIPUR FEIPLAR. Hoje eu vou apresentar para vocês aqui os desafios da descarbonização.
The challenges of decarbonization, how Covestro is driving the circular economy in the PU industry. Well, first to present Covestro to you. The company is relatively new. It has only existed as a brand for 9 years, but it has a very, very old or long-standing tradition working within Bayer in coatings, adhesives, varnishes, polyurethanes, etc., which were previously made under Bayer material science. All these facts and figures are for 2023. Some 1,300 employees, turnover of 14.4 billion euros. It's innovation-based. For R&D, 7 to 8% of its employees are directly involved with R&D and has more than 80 years of invention. It was in 1937 in Leverkusen that Bayer invented polyurethane. It has a very long or very extensive portfolio, isocyanates, TDI, MDI, polyols, a large range of polyols for a number of applications, flexible and rigid foams, aliphatics, thermoplastics, PU, and many other byproducts, blends and resins for the paints and varnishes market. We are present at 48 sites, production sites around the world, and we lie close to very major markets, working with customers and suppliers. This afternoon I'm going to be talking about the challenge of decarbonization. It's important to contextualize that a little bit because some of the data is for studies in Europe. The circumstances in terms of metrics and consumption of energy is not the same in Brazil. Our energy matrix is a bit different, but the logic is the same. We're going to talk about the year 2050, which is when the industry has the challenge of bringing all carbon emissions to zero. So the year of 2050 is what we are moving towards, and the clock is already ticking. Many buildings that are going to be used in the 2050s are already operating today, and these account for 39% of all emissions worldwide.
1/4 of these emissions result from the carbon incorporated in materials used in construction. It can be in steel products, in plaster, in plastics, and many other materials that are used in a superstructure of buildings or in coating materials. Once the operational carbon for you to keep a building working is reduced through energy efficiency gains, electrical components, refrigeration systems, thermal insulation. This operational carbon is reduced. The importance of focusing on incorporation carbon grows with the goal of zeroing the carbon emission goals. Thinking of a building that is being constructed today in 2024, 50% of the carbon footprint of these new constructions will come from the operational part, and the other 50 from materials that are incorporated in the construction, the so-called incorporated carbon. So it's very important to think of a building, how much this incorporated carbon footprint can be contributing to the total emissions. And thinking in Europe, 80% of buildings that will be used in to 2050 are already being used today, are already built. And 35 of the European buildings are more than 50 years old. And what does this mean? The efficiency of these buildings is very low. So deep renovation to increase energy efficiency is necessary. There will be an increase in incorporated carbon. These materials that increase energy efficiency usually are thermal insulators that today use fossil resources coming from oil in their composition. So how do we think about where carbon comes from? As I said, the sources of incorporated carbon are in the superstructure. Of course, they have a great contribution for steel, concrete, brick, and glass, plastics. All of this contributes to the increase in incorporated carbon. To decarbonize in the industry, you must have a full transformation, increasing the efficiency of plants, reducing the consumption of energy in the production of materials, using clean energy sources, replacing the sources of materials from petrochemical resources to renewable resources, and changing methods of production with technologies to capture carbon with renewable energies. Recycling and reuse are also very important technologies. And we need, when designing the new building, to consider the minimum use of materials, the reuse of elements, and to specify low carbon materials. So it's important to design this from the beginning, so that this building will be sustainable in the future from the point of view of feasibility. How is Covestro approaching the pathway for these low carbon materials? After explaining the importance and the why, we must think of the solutions that we propose to the industry and how can Covestro contribute to the projects to reduce carbon footprint. Speaking of our 4 pillars as an industry, in your sustainability agenda, in our sustainability agenda, we have an internal pillar that is to pursue carbon neutrality with the use of clean energies, and several other internal actions in order to reduce the consumption emissions of carbon of our internal operations. On the side of our products, we are designing them with alternative inputs in order to deliver products with low incorporated carbon. Also technologies that allow the efficient recycling of materials that until today are expensive to be recycled, or the degree of purity of these materials does not show the same quality of the originals manufactured from petrochemical resources. In terms of strategic partnerships to create ecosystems that promote innovation and recycling, sustainability, and everything we can do in order to incorporate these new raw materials in our chain. Because sustainability, it's only through partnerships that will be environmentally friendly, economically viable, and socially friendly as well, so that people can benefit from that in the long term. So our goal in our metrics, in our carbon metrics, is to be carbon neutral in scopes 1 and 2 by 2035, 60% of reduction in scopes 1 and 2 in 2030, and this is part of our agenda, it's part of our sustainability publication. Covestro has always published goals in scope 3 in terms of carbon emitted in our materials that we intend to zero until 2050, and we are aligned with the climate goals of the Paris Agreement that do not allow the global climate to warm up more than a degree and a half up to 2050. Where do our materials come from? This is a key for everything. To reduce the incorporated carbons is in the products, in the basic inputs. Our raw materials may be manufactured through vegetal sources, bio-based as they are known popularly. It involves the use of vegetable oils of second generation, the use of these oils that originally were thrown away. You can, in the petrochemical chain, to reincorporate that. To obtain petrochemical resources through plastic materials that are disposable in the circular closed chain. I usually say that my dream career is to see that mattresses would be collected and this foam is deconstructed into new polyols and TDI. So all of these projects and initiatives are ongoing, but these two first ones of heavy materials that are biorenewable vegetable materials or biocircular chains, they are already reality. These products are available. This is a key for you to advance in direction of a climate neutrality, circular economy, and to reduce carbon emissions based on fossil resources. And another challenge is how can I incorporate these materials of vegetable origin or recycled materials into constructions as complex as TDI, MDI, or polyols that are the main inputs for civil construction. In the foams, in the insulation foams used in the civil construction, you cannot build a plant just to incorporate renewable resources. So in your own chain, you must create methods that together with your fossil resources, you may allow you to gradually increase the number of renewable resources. The key for all of that, it's a methodology of mass balance. I will explain what it is and why to use it. The mass balance methodology basically means that in the petrochemical industry, when you receive the oil to create benzene and toluene, you add other alternative inputs. In green, you have renewable content material, and in gray, the naphtha of a petrochemical origin. These materials are incorporated together in the beginning of the chain. Here you have a production of benzene, which is the basic raw material for MDI. And it's a mix of both renewable, sustainable sources, and in gray, the petrochemical materials. These materials are processed. After they arrive at Covestro plant, you produce the MDI, and when you have the output, you segregate it through a mass balance and mathematical calculations, the percentage of material that was produced from oil and the percentage produced based on renewable sources. And all of this chain of raw materials that undergo different phases, they will have a custody chain that is followed up closely by international organizations. It allows traceability of raw materials along very complex chains, and they are incorporated to the productive process physically in the beginning. However, the final attribution is a mathematical calculation. And as I said, you have the certifying entities that in the end of the chain will make sure that products go to the consumer with a reduction in the carbon footprint of X%. And why should we use that? As I told you, first it's easy to implement. The physical segregation of alternative materials is challenging. You will not build a plant from the scratch just to use alternative materials. It allows the use of the existing units, so you don't need to create assets exclusively for that purpose. You have a fast gain in scale, and for our file customers, you have the same product without any change in quality of performance. You don't need to change formulas. There's low effort, low cost in the implementation. It's like major homologations of parts and tryouts are not necessary, and you can choose what sustainable input you use, if you are going to use it from a vegetable or biorenewable energy source, or the circular economy of open chain that we'll have shortly, allowing for the emissions of CO2 being reduced, reduction in the use of fossil resources, more investment in the circular economy chain, and they are very attractive in terms of our clients' demands. So Covestro is transitioning. Several of our sites have been certified in ECC Plus, and our DC in Brazil, when our clients ask for sustainable materials, they can, it already comes with the IECC certificate that is delivered together with the raw materials until they arrive to Brazil and they are sold to our clients. There's a portfolio available. We have an MDI that is 100% carbon neutral. So basically, the contribution to your products in terms of carbon emissions is zero. TDI and polyol with a reduction in the carbon footprint depending on the raw material that is used, and the raw materials of biocircular origin. They will also be available shortly as part of this portfolio. This approach is not new. Several industries already use ISCC Plus as a source of traceability for the sustainable raw materials. Even in agriculture, you can have sustainable management, and the industry that can manage their production as they please. So companies that wish to work for a specific public with sustainable management materials, they can use the certifications from many certification organizations that will certify the whole custody chain, making sure that consumers will have access to products that will contribute in a responsible way to the society, to the environment, without damaging forests, without using children's labor or child labor or even slave labor. Speaking of civil construction, our target is to work with thermal insulation that already contributes to the building efficiency through this insulation, but to make it more sustainable with low carbon materials. So we have our MDI that it's called Desmo Doors CQMS, the biocircular material. It has a content that is renewable, certified by ISCC Plus. The carbon footprint is reduced, and it will help our clients to comply with current requirements of a modern building, but also future regulations that are being prepared in Europe and United States, but that will come to Brazil, to Latin America very shortly, and with high insulation performance. These are safe forms, highly energy efficient. And here we bring you an example of our sandwich panels or insulation boards of more or less 12 centimeters of thickness with a density of 35, with a reduction of CO2 equivalent of 7 kilos per square meter of board. For comparison, a liter of fuel for you to drive for 10 kilometers, you emit more or less 3 kilos and a half of CO2 equivalent. So the reduction is very meaningful because the use of MDI in these pure core boards is very high, 75% of the MDI polyol mix. So it's a solution that will help the industry, that will help in this transition, because this is a journey. These solutions They are not magic. Will be built along the years. And the relevance of these topics, of these materials, will become more and more highlighted in order to comply with the goals that the nations are signing on. So to conclude, we have some ongoing projects. Bioaniline is produced from renewable raw material, and a very interesting project of circular foam obtained through chemical recycling. Then we have to deconstruct the polyurethane chain to obtain MDI, TDI, or polyol, to deconstruct it and reincorporate it in the value chain with virgin material of high quality. The performance of these products must be equivalent to the performance of current petrochemical-based products. To conclude, where will we apply these materials? Insulation, thermal insulation boards, OCF forms, OSB panels that are agglomerates free from formaldehydes produced with low carbon resources, sandwich panels, and also polycarbonate boards that can be produced from these raw materials of vegetable or biocircular origin. That's what I had to bring to you. I thank you very much for the attention and the presence. And if you have any questions, please do ask us. If we come to Covestro booth, it will be a pleasure to talk to all of you. Thank you.